Hello and welcome back to Math with Miss Murthy. Today's lesson is lesson 4.4 on rational numbers. So we're going to reason about rational numbers using a number line. We'll be comparing them, ordering them, all of the fun stuff. As usual, please pause and do the chess warm up and the check problems on your own. All right, so let's do a quick recall. We know that natural numbers, and I'm just going to denote that using n, which are the numbers 1, 2, 3, 4, so on and so forth, is the number of the set natural numbers. And then we have whole numbers, which I'm going to denote using wn, which is the entire set of natural numbers plus the number 0. And then the latest that we've learned are our integers, okay, which include our entire natural numbers and whole numbers and negative numbers like -1, -2, -3, and so on. We now have rational numbers, which can be written as a fraction a over b, where a and b are both integers and b is not equal to 0. Okay, a rational number, just like all other integers, can always be represented as a point on the number line. And you'll see here our set of rational numbers is the superset currently that we know of. Okay, so now, as I said, rational numbers and sets of rational numbers can both be graphed on a horizontal or a vertical number line. A set of rational numbers is written just like we did it for the integers using using braces, okay? So let's look at this set, which has -2.25, 2.25, -1/3, and 0. So to graph this on the number line, we're going to draw a number line and place a dot at the location. I have a 0, so I place a dot at 0. -1/3, that's over a dot at -1/3. And then 2.25. For each of these, we place the number on the dot on the number line, as well as we write our value that it corresponds to the original value in the original format, okay? So let's take a look at example 1, graphing the set of rational numbers, -1/5, -0.7, 2 and 3/5, and -1.8 on the number line. Forgive this typo, this should be 1.8, okay? So we first need to find our integer boundaries of the set. Now, why do we need to find these integer boundaries? Because we need to know how big our number line should be, okay? Now, if you look at this, you'll see that our values, the highest value is 2 and 3/5, and our lowest value is -1/8. So therefore, a number line with a smallest value of -2 and a largest value of 3, which is bigger than this, would work. So the values lie in the set between the integers -2 and 3. So we're going to draw our number line, and then we're going to rewrite the fraction and the mixed number as decimals so that it's easier to compare. So -1/5 is nothing but -0.2. 2 and 3/5 is 2.6. We're going to graph each value on the number line, and we're also going to label each point with the value in its original form. Therefore, we're not going to list it as 2.6, but we're going to list it as 2 and 3/5. All right, let's take a look at example 1. Graph the set of rational numbers, -1/7, 1.5, 2/5, and -0.6 on the number line. All right, talking about absolute value. Now, what we saw yesterday was an absolute value of an integer. We're looking at absolute values of rational numbers. And just like integers, the rational numbers 2.5 and -2.5 are each 2.5 units away from 0, even though they're on opposite sides of 0. Remember, yesterday we came up with the analogy of, say, tennis or a ping pong ball, okay, where it bounces from one to the other and then it bounces back, okay, the same distance. And we know that numbers that have the same distance from 0 on a number line have the same absolute value. Therefore, this positive number and the negative number are both have the same absolute value. Okay. All right. So again, in words, absolute value of a rational number is the distance between that number and 0 on a number line. So looking at our model here, I'm modeling negative 2.5 and 2.5. Okay. My apologies for the colors over here. You can see the absolute value of 2.5 is 2.5 because it's 2.5 units away from 0. Absolute value of negative 2.5 is also 2.5. Okay. Let's take a look at example 2. The lowest point in a certain cave has an elevation of negative 53.4 meters. So if the cave entrance has an elevation of 0 meters, evaluate the absolute value of negative 53.4 to determine the number of meters a hiker would descend to reach the lowest point. So again, we're going to graph this on a number line and see how many units from 0 is negative 53.4. So that gives us 53.4 units, or in this case 53.4 meters. Therefore, we can say that the hiker descended 53.4 meters. Pause and do the check on your own. All right. So to compare two rational numbers, we can compare the signs first as well as the magnitude or the size of the numbers. If the signs are different, the positive rational number will always be greater than the negative rational number. Okay. So again, let's compare 1.5 and negative 1.2. Here, the signs are different. Negative 1.2 is smaller or is less than 0. Okay. A positive rational number is always greater than a negative rational number. Therefore, we can conclude that 1.5 is greater than negative 1.2. Now, if the signs of two rational numbers are the same, we can graph them on the number line to compare them. Also, if the numbers are written in different forms, it will help us to graph the numbers as if they're both written as decimals or both as fractions. And then that judgment of which one you use is going to depend on each question, on each numbers, okay? And we know greater numbers are graphed farther to the right on the number line. We're going to use that. So to compare negative 1.5 and negative 1.2, we draw a number line. We mark negative 1.5, negative 1.2, and you can see since the signs are the same, we're using the number line, and you can see that negative 1.5 is less than negative 1.2. All right. Example 3, compare negative 0.51 and negative 12/25. Now, since both of these are negative, our comparison step goes one shorter, but one of these is in decimal form, the other is in fraction form. We're going to convert one of those. So we choose to convert negative 12/25 because it's an easy number that we relatively all know. And that's nothing but negative 0.48. If we were to graph it on the number line, we have negative 0.51, we have negative 0.48. You can see that it's to the right. The number negative 0.51 is farther to the left. Therefore, negative 0.51 is less than negative 12/25. All right, do the check problem on your own. Okay, now to order rational numbers so far, we've graphed them on the number line. We have compared them. Now to order a series of rational numbers, we're going to follow the following steps. We make sure that you write each number in the same form. Since there may be different denominators when we write in fraction form, it's always easiest for comparison if we can write all of them as decimals. Okay. Next, we're going to use the signs of the numbers and then the place value or a number line to compare the numbers. And lastly, we're going to order the values from the smallest to the biggest. Okay. So let's take a look at the set of numbers 1/4, negative 0.375, negative 7/15, and 0.3. And so we're going to graph each of these on the number line. The least value would be the farthest to the left, most would be farthest to the right. So if you look at this, we have negative 0.375. You have negative 7/15, which is nothing but negative 3400th or negative 0.34. So you can see that negative 0.375 is absolute value is greater than negative 0.34. So that's farther away. So you have negative 0.375 followed by negative 17/50th. And then you have 1/4, which has a decimal value of 0.25. And then we have 0.3. So the set of numbers in order from least to greatest is going to be negative 0.375, negative 17/50th, 1/4, and 0.3. And to order it from greatest to the least, we are going to go in the reverse order. Okay, right to left. All right, let's order negative 2.46, negative 2, 22/25th, 1/4, and negative 2 1/10. Now you can see that this is the only positive, so that's going to be my greatest. Now we only need to compare these three. So let's write them all as decimals. Our first one is given to us as decimals. Negative 2 22/25th would be nothing but negative 2 88/100, which can be written as negative 2.88. And then you know negative 2 1/10 is nothing but negative 2.1. So let's graph these on our number line. We have negative 2 22/25th, negative 2.46, and then negative 2/10. So that's the order of our rational numbers, followed by 1/4 to the right. Don't forget that one. Pause and do this check problem on your own. And that's all I had for you for today. I'll see you in class tomorrow. Ciao.